In this lesson, we're going to look at how to integrate sine and cos of a complex function. Now, since integration is the reverse process of differentiation, then to integrate cos, we get sine, and when we have a bracket here, instead of multiplying by the derivative of the bracket, we divide by the derivative of the bracket. And the same idea here, when we integrate sine, we get negative cos, and then we divide by the derivative of the bracket. These two sections here are in the formula sheet. You don't have to memorise them, but it is good to understand what's going on and not always rely on the formula sheet, but it is there if you need it. So let's look at some examples first. This first example integrates sine of 3x plus 2. So we have to integrate sine and we get negative cos, and then you differentiate the bracket, which is 3, and we have to divide by that. So we get negative a third cos, and then the bracket, and we remember to put our plus c at the end, a constant of integration. Looking across, we've got the integral of cos 5x plus pi over 2. When you integrate the cos, you get sine. The derivative of this part is just 5. So we get a fifth sine, then your bracket plus c. Don't be put off by the pi over 2 here. That is just a constant value, so when you differentiate it, it goes to 0. Moving down here, when we integrate sine again, you get negative cos. When we divide by the derivative of the bracket this time, we're dividing by 2/5. When you have something like that, 1 divided by 2/5, it's easier to see it like this. 1 divided by 2/5, and the way to deal with that is to flip the fraction over and multiply. So you're eventually going to multiply by 5 over 2. So we've got negative 5 over 2 cos, and then the bracket plus c. Same idea over here, we integrate the cos. This time we've got a 2 in front. That doesn't matter, we just need to divide the 2 by the derivative of the bracket. Cos goes to sine, so we end up with 2 over a quarter, like that. And then sine of the bracket plus c. And the same idea as this one over here. 2 divided by a quarter is the same as 2 multiplied by 4 over 1, which is going to give us 8 sine of the bracket plus c. Okay, moving on to a more complicated example to do with area. We want to find the area enclosed by the graph, the x-axis, and the two lines x equals 0, which is this line going up and down here, just your y-axis basically, and the straight line x equals pi over 8, this line here. So this trapped area here in the green is what we're looking at. So how do we do it? Well, we integrate the function, which is sine of 8x plus pi over 6, and we need to integrate it between the two values 0 and pi over 8. This is our upper limit, it goes in the top. This is our lower limit, it goes in the bottom. And remember, when you integrate between two limits in the function, it works out the area that's trapped between that area and the two lines here and the x-axis. So, when we integrate sine, you get negative cos. Divide by the derivative of the bracket, which is 8. So we get negative an eighth cos of the bracket. This time we've not got a constant of integration because we're actually calculating an area. So we need to substitute our values in our limits. So let's substitute the upper limit in first. And that will come out like this. If you substitute pi over 8 there, you've got 8 pi over 8, and then put the 0 in. So negative an eighth cos of just pi over 6, because if you put 0 in here, then that whole part just goes to 0 and you're left with pi over 6. So that's why we've got the cos pi over 6 there. So let's sort this bit out first. Now 8 pi over 8, the 8's will just cancel there, 8 divided by 8, and you end up with just pi. So pi plus pi over 6, now that's really like just having, if we think about this over here, that's like having 1 plus a sixth, pi plus pi over 6. So 1 plus a sixth, that's just like 7 over 6. So the same thing happens here. This bit just goes to 7 pi over 6. So that goes to this, negative an eighth cos 7 pi over 6, take away, and this part. So we have to work out what these values are. Now, cos of 7 pi over 6. To change radians into degrees, if you like, in your head, so as you can work these out, I always do the division first. So 180 over 6, that's 30. So you're talking about 30 times 7, that's the cos of 210. Now if you look over here, 210 degrees is about here. If you go round from 0, round, 90, 180, 210 is about here. So if we think about what that angle there is forwards from 180, you're thinking about the acute angle's 30. So this is really the same as the cos of 30, but it's in the third quadrant, so it's negative because that's the tan quadrant where the tan's positive and the rest of the graphs are negative. So it's really negative cos 30. So the cos of 30 is root 3 over 2, so that's going to be negative root 3 over 2. And the cos of pi over 6, well, pi over 6 is just 30, so cos of 30 is root 3 over 2, so we've got that there. We can sort this out, we'll solve the area. So if we multiply these two together, we're going to get a plus, because a negative times a negative, we're going to get root 3 over 16. This is going to give us negative root 3 over 16, but we're taking that away, so we're taking away negative, it's going to give you a plus. And if you add these two things together, you're going to get 2 root 3 over 16. The 2 and the 16 will cancel, and you basically get root 3 over 8 units squared.